Okay, guys, how you doing? This is a bit of an experiment. Notice the glare in the corner. That's another issue I'm trying to deal with. This is an experiment because I'm doing it without anybody holding the camera. I just sort of propped it up over here, and you'll let me know if you can see it and hopefully understand what I'm talking about. So the assignments I gave you today are based or predicated on understanding a real simple little idea that we'll talk about now. And of course, you'll get videos where I solve all these problems in detail. Let's take a look at what's going on, what I'm talking about. As you know, as we learned already, the circumference equals 2 pi r, and we were talking about that when we were doing functions. And we said that this was a linear function, and we made a little sketch and a graph of it. And now I'm saying that if you know the circumference in terms of pi, then the Common Core is trying to tell you that you know the radius, and that's absolutely certain. Check it out. I replace c, the circumference, with 50 pi. Right in the formula, and then we divide, as we always do in algebra, both sides by 2 pi, and it turns out then that 25 equals r, because all the pi's are canceling out of there, and half of 50 is 25. Well, following the same sort of reasoning, if I know the area of a figure, then of course I know the radius, and here we go again. If, say the area equals 25 pi, okay, just to make the numbers easy, then I write area equals pi r squared, and since the area is 25 pi, and since it's been explained so many times, pi is just a number, I'm divided by both sides, and I get 25 equals r squared. Well, how about that? We're back a blast from the past. When I put the hat on both sides, as been explained in our course on Pythagoras, 5 equals r, because 25 is one of our old friends, a perfect square. And this is a demonstration that things are going to get out of control here pretty soon, because not everybody's a perfect square. And we'll have to start dealing very shortly with the idea of irrational numbers. After all, pi is an irrational number, and we're going to have to start accepting them and using them in our math exercises, but not now. So let me give you an example, a problem that you can do now, a simple problem. Again, the numbers are carefully chosen so you can do these problems. You have a cylinder here, and they tell you that the circumference is 20 pi. All right, and then so here, all this circular area around the top, this length is 20 pi. And you want to know what the radius is. And of course, you're missing a little data here. You can't answer that question because you're going to find now the volume. All right? So given the circumference, I can tell you what the radius is because I can tell you what the radius is and thus tell you what the volume is. And when we put a number in here for h, you'll see what I'm talking about. So one more time, just to slow things up, given the circumference, that means I can find the radius, but that in turn means I can find the volume. So it's very common for them to ask questions like that on the Common Core test. One of your questions is definitely doing the same thing. So let's do the math here. We know that the volume of a cylinder is 2 pi r squared, it's pi r squared h. So now I just do a little razzle-dazzle here. 20 pi, got to stop that again.